This is my 4.3 data collection methods. During this time we're going to be looking at the different types of research designs, the classification of data, qualitative data and then quantitative data. For a researcher it's very important that they choose the right way to collect their data. This is important because they'll want to get reliable and relevant data to support their case or hypothesis. When the researchers are deciding what the best research design is, they will have to take into consideration like whether or not they want to get numerical data or descriptive data, how long they have to do the study, whether they want to be able to generalise their findings, and whether or not they have time, money to do some of them. So there are 6 research designs. You've got case studies, cross-sectional, longitudinal, comparative, correlation and experiment. After the researchers have chosen one of the following research designs, they must then decide what research method they're going to use and then how they will go about actually collecting the data. So the first one is case studies. So this is a certain piece of research focused on a particular person, group or situation. So it's deliberately trying to isolate a specific group of people, one individual case or an individual group. And this is normally long term, so it's usually performed over a long period of time. So the advantages of this are that rich data is collected and it also provides further insight into further research. The disadvantages, however, is that it can't be generalised, it's difficult to replicate, time consuming to perform, there's low reliability and it also can be biased if you're doing the research yourself. And for example, they could look into a group of 17-year-old British GB gymnasts and then put them on a specific programme to work on their weaknesses and then see if over a year whether the programme has worked and these weaknesses are turned into strengths or not. So the next one is cross-sectional, and this is when the researchers observe but don't interfere, and it kind of takes a snapshot of what is going on at a certain time and different groups are compared at one time. So the advantages of this is that it's quick and easy, it's cheap, it's good for descriptive analysis and for generating a hypothesis, and it captures a specific moment in time, and the findings can then go on to create new theories which then either you can work on or other research can work on that. The disadvantage, however, is that it's susceptible to bias due to a low response, and it can also it can suggest the cause and effect, but it can't prove why this happened. So, for example, you could look at the flexibility of female gymnasts and put them into groups, so from the age of 6 to 10, then 11 to 15, and then 16 to 20. So, longitudinal. So, this is research that is done on the same subject, so over many years, looking for changes over time, and the research also doesn't influence participants. So, for example, to conduct a longitudinal study, they might conduct a longitudinal study to determine whether the muscular strength of a young female gymnast has changed over 3 years, and then focus on that specific gymnast and just see if they've improved at all. So the advantages of this is that it's effective in determining patterns over time. It can ensure clear focus and validity, and it's highly flexible as well. So the disadvantages of it is that it's an elongated process, which means that it takes long periods of time to do, and also you risk gathering data that is not 100% reliable, and it also requires quite a large sample size. Comparative, so this incorporates quantitative and qualitative data together, and it compares the similarities and differences and patterns across 2 or more cases which have a common focus or goal, and this is often done as a survey. So the advantages of this is that it clearly states the differences or similarities between the cases. However, the disadvantages are that the categories may be defined differently in some countries. So, for example, different countries may have a different definition for body composition, and you also then need a large population sample to make sure that it works out well. And so an example for this is to compare the body composition of a GB gymnast to a Chinese gymnast. Correlation is used to see if there are any relationships between two or more non-manipulated variables, and this can give you a positive or a negative correlation. So if it is closer to +1 on the scale, then that means that there is a very strong positive correlation. However, if it's towards -1, then that means there's a very strong negative correlation. However, if the numbers say like 0.3, then it's still it counts as a positive correlation, apart from it is a very slight, so you may not be able to use this as like a full positive correlation, but it still will show a little bit. So the advantages are that it's more applicable to everyday life, and other researchers can then research it in further. And disadvantages might not show a correlation, and it only uncovers the relationship. It doesn't actually explain why this is, and also it doesn't show which variable influences the other. So if there's an increase with one variable that leads to an increase in another, it will lead to a positive correlation. However, if there's an increase in one variable that leads to a decrease in another, that'll be a negative. So an example is to look at how the height of a gymnast relates to their weight. So experiment. So conducting an experiment is one of the most common research methods. The researchers will firstly discuss and then make a hypothesis that they're going to test. They then collect data by manipulating the independent variable to see what effect it has on the dependent, which is the one that they measure. They will then analyse the data they have collected and then compare it to their hypothesis. And there are 3 parts to a true experiment: randomisation, manipulation, and having a control group. So randomisation is when the participants put into sample groups in no particular order, so they could be like numbered and then put into groups. Manipulation is when the researcher changes the variable in the hypothesis, which is the independent variable, and then to see what effect this has on the dependent variable. The control group is when they do not get manipulated anyway, and they serve as a baseline to see if there's any changes between this group and the experimental group. And the advantages of this is that the researcher gets to control the pace fit, the location, and the environment of the experiment. There's good internal validity because obviously they get to choose where they do it, and it's also less bias. Disadvantages, however, is that it can't be generalised, especially if it's done in a lab. There's problems with ethics, health and safety, and participants know they're being watched. They might change the behaviour to do like what the researcher wants them to do. For example, you could see whether warming up affects a female gymnast's muscular endurance. This could be conducted by doing the wall sit, and there would be 3 groups. So a control group that doesn't do a warm up at all, one group that warms up 5 minutes, and one group that warms up for 10 minutes. And each group will do the wall sit at the start to get a result to go by. They will then all have a 15-minute break to recover, and then the control group will do it straight away again, and the other 2 groups will warm up for that allocated time, and then they will do the test again. So the types of data. There are primary data and secondary data. So the positives for primary data is that it's reliable. They know, and you know how you've done it. However, the negatives of it are that it's time consuming, it's expensive, well, it can be expensive, and it's also down to kind of trial and error, and you can be biased towards it. You can, if you want something, if you want like your hypothesis to be true, you might change and manipulate the situation to make that right. And secondary data, the positives are that you can research it further, it's cheap and readily available. However, you don't know if it's reliable, and it may not answer the question you're looking for, and it's also not as much detail. You don't know whether they're credible or not. So primary data is what you do, the data you get yourself, and secondary is data that other researchers got. So for example, you could choose to do your own research as to whether young female gymnasts are more flexible after they've warmed up, and then get your own results from that, or you could use someone else's results to try and build on what they already have to get more data. So there are 4 classifications of data: discrete, ordinal, nominal and continuous. Each of these will be useful for different things, and researchers may use a mixture or just one depending on the research they are looking for. So the first one is discrete, and this is you only get separate, isolated or opposite values that can be achieved from this. So it's only like a two-way answer. It's either yes or no, whether you're male or female, left or right-handed. So yeah, things like that will be gender. The next one is ordinal. So the data is ranked in order. So for example, like if you are positioned in a competition, you've got first, second and third. It also doesn't have to have equal intervals. So you can put them in order. So from height, the tallest one end, smallest the other end. However, you wouldn't know whether the tallest is 6 foot and the second tallest could be 5 foot or something. You wouldn't know what the difference is between them. The next one is nominal. So the categories are all named, and there's no order to it, and it's not descriptive. So example for this could be gender, or another example could be like eye colour. So they're just put in categories apart from you don't know like much about them. And then the last one is continuous. So you've got two types of continuous. You've got interval and ratio. So interval is when you put it in rank ordering, and it's approximately equal intervals between each ones. This can have negative numbers. So for example, temperature, you can go below 0 into -1, -2. And the difference between the numbers is known, unlike the nominal. And also ratio is there's equal intervals in between. There is an absolute 0, so you can't go into negatives. And it's rank ordering again. And an example for these is heart rate and time, because you can't get a minus heart rate or a minus time.